Hi guys, so today we're going to look at a third example of multiplying radical expressions. In this particular example, it's just a bit more hefty. The multiplying is actually the easy part. The simplifying is sort of a throwback to last week when we had these big radicands that we were simplifying with multiple variables. So I wanted to sort of throw this in as its own separate example in case you guys need a little bit of review with the simplification piece of it. So let's take a look. This is just a quick reminder of multiplying radical expressions and the rules. We're going to distribute, simplify, and combine like terms. And just remember, when you're multiplying radical expressions, anything on the outside of the radical can be multiplied with anything on the outside of the radical. Anything on the inside of the radical can be multiplied with anything else on the inside of a radical as long as the index is the same, but you can't take something from outside a radical and throw it inside the radical and multiply those things together, okay? So insides stay with insides, outsides stay with outsides. All right, so let's take a look at this example. Here's our last example that we're going to look at today. I think this one looks the most complicated, but it's actually kind of the easiest one to deal with, in my opinion. It's not nearly as bad as it looks because we're just basically multiplying two radicands together, you guys. And we know that by the rules of radicals, when we're multiplying together, anything that's underneath the radical can be multiplied with anything else underneath the radical as long as the index is the same, and indeed it is, right? So we're just going to multiply 8x cubed y to the fifth times 4x squared y to the third and keep it underneath the radical. So here I've just rewritten it so that we have that first term, 8x cubed y to the fifth, being multiplied by our second term, 4x squared y cubed, okay? So when we do that, we're just going to multiply together piece by piece, okay? So we had two numbers, 8 and 4, so 8 times 4. We're going to multiply those together. X cubed and x squared, we're going to multiply those together. We're just multiplying together like variables and numbers. Y to the fifth, y to the third, we're going to multiply those together, which gives us 32, x to the fifth, y to the eighth, right? 8 times 4 is 32. X cubed times x squared, we just add those exponents. So 3 plus 2 is 5, which gives us x to the fifth. And then, of course, so here's our 32, here's our x to the fifth. And then, of course, we have y to the fifth times y cubed. We're going to add the 5 and the 3, which gives us y to the eighth. All right, you should always be asking yourself, can I simplify further, okay? And if you remember back to last week when we worked on simplifying radicals, well, yeah, I can simplify this a lot further, actually. I can simplify each one of these pieces. All right, so I'm dealing with the fourth root, which means I want to factor these things, and I want to factor the number, and then I can use that cool trick where I take the exponent and divide by the index, if you guys remember that from last week. So I'm going to start with the 32, and I'm going to break it down into its prime factorization. So the first two factors I think of are 8 and 4. These are not prime, so I'm going to keep going. 4 and 2. This one's prime, but I have to keep going with this one. 2 and 2, okay, prime and prime. Same thing here, 2 and 2, prime and prime. So now I have all prime numbers at the bottom. I can stop. So 32 is equal to 2 times 2 times 2 times 2 times 2, okay? So that's where this piece came from. Now I know my index is 4, which means I'm looking for anything that I have 4 copies of to pull out, okay? And do I have 4 copies of 2? I sure do. 1, 2, 3, 4. In fact, I have 5 copies of 2, which means this last one's just going to have to stay underneath. So 4 copies are going to pull out as 1 copy on the outside, right? So I'm going to be left with 1 copy of 2 on the outside, and then of course this lonely 2 has to stay on the inside, and I don't want to forget to write my index, so I'm going to put it there now. So now I'm going to deal with this next piece, my x variable, and I know I can jump back and forth between exponent and radical form because they are inverse operations. So x to the fifth, that means I have 5 copies of y underneath the radical, but I need to take 4 out. And like we discovered, that just means we're dividing. All right, so this is x to the 5 divided by 4th power, which is going to mean that, yeah, we did get 1 copy of x out, right? We're dividing by 4. So if we had 5 inside and we took 4 of them out, well, we got 1 x out, but then, of course, an x had to stay, okay? Because 4 of them came out, but we had 5 to begin with. So one of them has to stay underneath. And then this last piece is a pretty easy simplify because 8 divides by 4 evenly. So that leaves us with y squared. Okay, which means we were able to get 2 copies of y out, which makes sense. If we're trying to take them out in groups of 4, right? We had 8 y's underneath the radical, and we're taking them out in groups of 4, which means we got 2 groups of 4 out. So that translates to 2 y's on the outside. So this is actually our answer, all right? I'm going to write it a little bit more nicely for you, and let me erase it. So we were left with, when all was said and done, we multiplied, we simplified, we were left with 2xy squared times the 4th root of 2x. So we had a 2 left under there, an x left under there, and then we got out a 2x and a y squared when we simplified everything. Okay, so that one was a bit more complicated, but really the complicated part was the simplification, which we already know how to do. The multiplication here was actually pretty easy. It was just a matter of multiplying these 2 terms together. So I think the multiplication piece is the easy part. The simplifying, we've already practiced, so hopefully you guys have a pretty good feel for how that should be done, right? You're just sort of thinking about, okay, I have this many copies underneath. The index is telling me I need to look for groups of this many to pull out, all right? Because exponents and radicals cancel each other. They undo one another, all right? The exponent tells us how many copies to put in. The index tells us how many copies to pull out. Here are those same examples from our previous video. So hopefully now the last one should seem a little bit more easier if you were struggling with it before. All right, reach out with any questions. Good luck. Have fun.